Okay, so now that we have finished talking about the data model for sharing threat intelligence with sticks, I have some time. So, I have like 4 classes including today. So, I am going to use that to give you some introduction to SCAP, which is the Security Content Automation Protocol. So, this is something that came out of NIST. So sticks is actually a security content, right. So, you are basically sharing threat intelligence in some stylized format, which can be parsed by tools like firewalls and intrusion detection tools, endpoint detection tools, to make various kinds of configuration changes and various kinds of actions they can take. So, sticks is part of security content automation, but we are not talking about threat intelligence. We are talking about checking the devices, the endpoints with automated tool for presence of vulnerability, for presence of configuration mistakes, and for presence of any kind of lack of patching. This kind of information I want to automatically check on every device on my network. So, if I could do that, then I could basically have a console from which I connect to all my devices in the network, and then I will run a scanner which will check whether every device has the right configuration, whether every device has the right patch, or whether every device has any or whether the device version or application version, etc., have known vulnerabilities, and report to the console that in your 1000 devices in your system, so and so device at so and so location has these problems. So, I will be able to see that, and then I will be able to actually try to do patching and other activities. So, that is what we mean by automation. So, I want to automate checking for vulnerabilities and configuration mistakes, and I want to also automate checking patches and all that stuff, or also other things like signs of compromise and so on. So, so to do that, first of all, what do I need, right? To do that, first of all, I have to, if I want to automatically check that this Windows 10 machine has any vulnerability or not, whether its configuration is correct or not, whether it has the latest patch or not, what do I need, right? I need, first of all, a definition of what it means to be the correct configuration, right. So, I have to have a configuration benchmark or a standard configuration for Windows 10. Similarly, within that Windows 10 machine, I might be running Microsoft Edge or Firefox or Chrome. I might be running various other applications, and for each of these applications there may be thousands of different possible configurations. So, how do I know what by automatic scanning that the configuration of all the applications are the most secure possible secure configuration, whether it is compliant with let us say standards like HIPAA or standards like PCI DSS or any other kind of standards that requires the configuration to be of a particular type. Then I have to have a way of writing what is the correct configuration. So, that is one thing, I need to be able to write in a way the configuration correct or secure configuration or acceptable compliant configuration using some kind of a common language, such that the tools can read that and then compare that against the existing configuration of the machine that it is checking, right. So, I need to be able to define the benchmark configuration. So, that is one requirement. Second requirement is that if I want to check for vulnerabilities, common vulnerabilities, then I need to check, I need to be able to express what I am looking for, what kind of vulnerabilities I am looking for. So, I have to have a way of defining vulnerabilities that I look for in devices. So, I need a language for defining vulnerabilities and how to test for those vulnerabilities. So, I have to have a way to, I have to tell the tool that this is what you should check, or this file you should check, or this configuration you should check to know whether that particular vulnerability is there. So, I also need to also know that if I need to also know whether it has the right patch level, then I have to go and look up the exact version that is running on that device, and then I have to go to some kind of a database which tells me that what is the latest patch for this thing, and I should not make any mistake about that, right. So, Windows 10 might have many versions, right. So, Windows 11 may have many versions, including different versions for different language. There is a Chinese version of Windows 11 and maybe a German version of Windows 11 and an English version of Windows 11. Similarly, it may have multiple different patch levels and so on. So, I need to know exactly which machine I am talking about, which application I am talking about, and I have to be very precise and exact. To do that, I need some kind of a way to express the most uniquely and most precisely the software or hardware or application, etc., in some standard format. So, I need a standard way of expressing what is it that which application or which operating system or which firmware we are talking about. So, I need a standard way of expressing what we call platform. So, which platform I am talking about. So, I have to have a way to do platform enumeration. Similarly, when I am talking about configurations, like in the beginning I said that I need a language to express which configurations settings are correct. So, but to talk about configurations, like which configuration I am talking about? Am I talking about the configuration about what is the longevity of passwords in the system, or am I talking about whether a particular registry key has to be set in a particular way? So, these configurations, which configuration I am talking about, that also has to be standard. There should be a standardized way of saying I am talking about this configuration or that configuration. So, I have to have a standard way of talking about configuration. So, I need a language for configuration enumeration. So, all these things are part of this SCAP standard or SCAP vocabulary, and that is why it is actually a collection of standards. So, it is not a single standard, but it is a collection of standards, as we will see, which has multiple different components for naming the platforms, for naming the configurations, for naming vulnerabilities, for measuring importance of vulnerabilities, for expressing what are the correct configurations, for expressing what vulnerabilities we are looking for. So, I need different standards for all these things, and this collection of standards is altogether is called SCAP, or Security Content Automation Protocol, and it was defined by NIST way back in 2009 in the NIST IR 800-117 document, and we will see that there has been number of other things that has been created. So, as I said that this is a super standard, 7 individually maintained standards put together is called SCAP. So, it guides how to identify a platform uniquely and unambiguously, right. So, if I write a platform in the way they ask us to write, then I will uniquely identify that, okay, I am talking about the Windows 11 so and so patch number and so on. it has a it's a standard to encapsulate guidance, and by guidance I mean the benchmarks, like how to best configure your application, or how to best configure your operating system, or how to best configure your hardware and so on. So that guidance has to be written in such a way so that it can be automated, it can be understood by a program, parsed and understood by a program, and action can be taken to set the configuration correctly. And so, how do you know what guidance applies to what platform? And that is where the use of the SCAP protocol, and SCAP basically links the various security automation standards. So, it provides a guidance on how to use the component standards and how to validate compliance with this guidance. And there is a tool. So, next class we will look at the tool, and you can also download, it is a free tool called SCAP. You can download and test the whether your machine actually, your Windows or Linux version actually is according to standard benchmark, and we will get the standards from US Department of Defense standards, or we can go for CIS standards. So, there are many standard benchmarks for secure configurations. So standards, in the class we have not talked about standards much, right. So we have talked about ATT-CK, that is a framework. We talk about MITRE Defend, which is a framework, which talked about NIST CSF, which is a framework. We talked about Lockheed Martin kill chain or unified kill chain, those are also frameworks. And then we talked about the various languages like STIX, for example, or we talked about risk assessment. Now, during the discussion on risk assessment, we talked about some standard way of doing risk assessment, very a little bit. We mentioned that there is COBIT and various other way of doing risk assessment, and we kind of showed how NIST risk assessment guidance is used for risk assessment. And we talked about resilience also. There also it's a maturity model, right. So we talked about a RMM, or resilience maturity model. Now, standards are actually very important, not only for security, but in general, right. So for example, when we buy a phone, for example, and we have a Bluetooth, nowadays all phones, smartphones have Bluetooth, right, or non-smartphones also have Bluetooth. Now, this Bluetooth will work with any device, any, let us say a earpiece, headphone or something that is Bluetooth enabled, and your phone is, let us say Samsung, and that thing is another company like Boat, and they work immediately, right. How do they work? Because Bluetooth has been standardized and the standard has evolved. So currently there is a low power BLE, right, low energy Bluetooth, and that is what everybody implements. The fact earlier, before Bluetooth and came, there was few other ones like Zigbee, etc. But the fact that earlier, even before that, companies used to have their own protocols for communicating with peripheral devices. Now, when companies start having their own protocols, then you cannot do plug and play. You cannot buy a new equipment and connect to that device, which makes it very difficult and also makes you bound to a particular vendor, like Apple tries to do for Apple users. But what standards do is that to actually allow the industry players to come together and define a common vocabulary, a common protocol that everybody will implement, and then it will be easy for others to come in and plug into that, and also it will be easier for others to also check whether you are compliant with a particular set of rules or protocol or engagement, rules of engagement. So standards, like we talk about 27001 standard, right. So ISO 27001 standard is actually the what we call ISMS standard, right, information security management system. How do you manage the information security of an organization? So if you want, if you want to be satisfied that the company you are working with for something, like for example, they are supplying something to some software to your organization, and you want to know that if that company is following proper security, which is in protecting the data that you share with them, or in the intellectual property you share with them and so on. How do you do that, right? So one way to do that is to go and check yourself. So you send somebody from your organization and say, okay, go and look into their cybersecurity management system, and if everything is fine, then only we'll do business with them, right? But that will be very, very onerous for companies, because a single company might work with many suppliers. So if you have to go and check with every supplier individually, that will be very difficult. So what you need is to see whether those companies that you work with actually has implemented their cybersecurity according to a standard such as ISO 27001. Now if they are according to ISO 27001, then you have to know that whether they really have implemented ISO 27001. So you have to look at their audit report, because if you claim to be implementing ISO 27001, then you have to maintain an audit where auditors will come and check your system and say, okay, so here are the places where you fail to maintain the standard, and you have to fix it. And once they fix it, then they call back the auditors, and auditors double check and say, okay, now we are satisfied, so now we certify that you are 27001 compliant, right. So that is how the standards are used, right. So similarly, in case of systems like OT systems, industrial control system, the standard is IEC 62443 or ISO 62443. So then you have to, if you claim to be compatible or implementing 62443, then you have to get a qualified auditor who can certify you that you are actually indeed compatible with that. So standards are good thing, right. So standards are a way of having making a problem, give you a handle on the problem, right. So if you want to check the security of other organizations, if you are a regulator, for example, if you are Reserve Bank of India, or if you are CVE, for example, or if you are the CEA, the Central Electric Authority, and you have the industry regulation as part of your charter, then you may want to have auditors certify that they are compliant with some standard or some guideline, right. So not all guidelines become standard. Guidelines become standard when there is a kind of consensus across industry that this is what is good for everybody. So now standards also give you a vocabulary, right. So standards, using standard we can use common terminology so that we can talk to each other, right. So for example, say I am talking about a Log4j vulnerability, and you are also talking about Log4j vulnerability, but there were multiple Log4j vulnerabilities, right. So which one are we talking about, right. I have to know a standard way of naming the vulnerabilities, so that two people, when they are talking about the same vulnerability, they use the same name or same string to express that vulnerability, whereas a slightly different vulnerability will have a different name, and therefore we should be able to figure out that which one we are talking about. Similarly, when we are giving a policy recommendation, right? So whether that policy recommendation means what it really means, right? So what does it mean to do, for example, risk assessment and risk driven security, or what does it mean to do asset management and things like that. So without standards, we will be talking cross purpose. So we will be saying probably same thing with different language, or we will be saying different things with the same language. There will be huge confusion. So it gives you common understanding of what it is that we are talking about, and then it gives also common baseline of capabilities, right. So when we are writing a benchmark, or writing that this is what the configuration should be, or this is what this vulnerability should be checked, you know, I should have a common baseline of capabilities that I am going to talk about. And but the biggest advantage of this is that suppose I write a benchmark configuration for Windows 11, and then I can actually make it available to anybody and everybody in the world who uses Windows 11, right. So if I had my own proprietary language to write the baseline configuration, then I could not have shared it, right, because if I shared it, you would have to interpret it you know, using your own knowledge and understanding, and you will probably interpret some of the things wrong. And certainly tools cannot be interoperable, like, so I have you know, same guidance or same benchmark cannot be used by multiple different tools. But if you have a standard language, then I can write a benchmark, and then I can create a shared content repository so that everybody can use it. And we will see that US Department of Defense has a very extensive content repository that is open for everybody. Also, you have CIS benchmark, which is also a very good repository of benchmarks for secure configuration. Now, one problem with all this is that suppose you use US Department of Defense standard benchmark for configuration, and you find that your organization, all Windows machines have, you know, you upgrade all your Windows machine to a compliance with respect to the US Department of Defense benchmark. Now, how do you know that they are not actually hiding the proper benchmark and then showing you a weaker benchmark, right? So that you leave some of your configurations weaker, right? You do not know that, right? So you have to have the ability, and you have to learn to actually check that benchmark and customize the benchmark according to your organizational needs, right? So you can, and there is a way to modify the benchmark. You can add additional properties to the benchmark to make your benchmark more customized for your organization, provided you know the standard and you know the language, right. So, and then as I said that if you have a standard, then all the content that you create, benchmarks and everything, will be compatible with respect to the tools, and therefore you have vendor neutrality. You do not have to get you know, one particular vendor all the time. So here is the main document where they first talked about adopting and using the SCAP protocol. So how to use SCAP in one's enterprise and how to create tools that fit into the SCAP compatible architecture. And then they came up with this special publication 126, where they actually give a full specification of the protocol. So this is more like a user guide, and this is actually technical specification of the standard protocol. And then this 7511 is actually an upgrade, like a newer version of SCAP, that is SCAP 1.3, that has the how to validate whether you are compatible with the requirements to be SCAP compliant. So that's the set of documents that are relevant here. For this class, we do not need to go through those documents and so on. I just want to get you familiar and understand the basic ideas behind this. So, I will not ask you to write SCAP content for this class, but you will be familiar because this is very going to be useful moving forward if you are into cyber security field. So, the NIST, the National Institute of Standards and Technology, obviously is a main organization that came up and spearheaded this. Also National Security Agency and Department of Homeland Security were the primary funders. And then there is also Department of Energy, that is the regulator for energy systems. And then there were also involvement of Microsoft, Red Hat, Sun is no longer there. So, Sun is part of Oracle now, IBM, Cisco, McAfee, Symantec, SANS Institute, MITRE and others. And then they also had mailing lists through which the users also could comment as the original thing was being developed. Now, there are three types of things, like I said that there are 7 standards, right. So, the 7 standards, not every standard is alike, right. So, for example, some of the standards are what we call enumerations or they are dictionaries. For example, how to uniquely name in an application or how to uniquely name an operating system or how to uniquely name a hardware system, right. So, that's basically what we call enumerations. So, that's dictionaries used to provide common identifiers for items. It is not a database, it has enough information to clearly describe the instances of a given item, and you can have additional information in a separate database which is not part of the standard. Now, so there are a couple of enumerative standards, right. So, how to name things. Then there are some standard languages, like STIX is a standard language. Similarly, here we have 3 different languages. One is called XCCDF, another is called OVAL and another is called OCIL. So, there are 3 different languages. So, XCCDF is to write common benchmarks for common configurations. OVAL is for writing the tests for vulnerability, and OCIL is for interacting with the users. It is not that important, OCIL is least important of all this. So, it can be interpreted by either people or software to guide activities, like how to change the unsafe configuration to a safer configuration, for example. And it also provides a structure and organization which would otherwise be narrative content. Like we saw then in case of STIX, we could have written natural language that this is the threat actor and this is how the threat actor is using this malware and this malware has these indicators. We could have written that as an English narrative, but to share that and quickly ingest that information into tools, we created a language, the STIX language. Similarly, there are languages which make things easier to actually get compatibility. And then one of the standards is a metric. It is an algorithm that helps users rank importance of items. In our case, it will be the importance of vulnerabilities, which vulnerability is more severe than the other. So, here are the names of the standards that are part of SCAP. So, this one you might have seen already. This is CVE or Common Vulnerabilities and Exposures. This basically is a unique way of naming each vulnerability which is discovered around the world, right. So, usually they are named like CVE dash year of discovery, then a number, and that number is actually we will talk about how that number comes, but after the numbering has been done, it becomes unique, and all tools will be able to recognize this using that number which vulnerability we are talking about. And this is very easy because the vulnerability database, there is a NVD, National Vulnerability Database, maintained by MITRE. This National Vulnerability Database has an API. So, you can actually call the API and look up every vulnerability. You will know exact information like what is the severity of the vulnerability, what platforms on which this vulnerability has been found, and what is the configuration mistake, what is the configuration that might actually expose this vulnerability, and so on. So, CVE is a way of enumerating software vulnerabilities. Actually, it should not be software only, hardware vulnerabilities also are named with CVEs. So, it should be actually enumeration of vulnerabilities. The second one is the CCE, or configuration enumeration. So, when we talk about configuration, like how many times a password should be mistried before your system locks out, that is a configuration, right. Some systems configure it for 3 wrong attempts and then locks. Some configures it for 5 wrong attempts, some configures it for as many attempts as the user pleases, which is pretty dangerous, right, which basically is an invitation for brute force. Then the question is that after you lock the system for wrong tries of password, how long is the lock? Is it 10 minutes, is it 24 hours, is it 1 hour? That is also configuration information. So, similarly, how often is the password required to be changed? Is it every 6 months, is it every 3 months, is it every 15 days, or is it, you know, as long as you want you can keep the same password, right. So, that is a configuration of the system. Similarly, what is the length of the password? Is it like 6 characters, 8 characters, 12 characters? That is a configuration of the system. What should be the what are the different characters that are allowed or disallowed or required in the password? That is a configuration information. Whether you need 2-factor or single factor is enough, whether you are allowing single factor after initially doing 2-factor for the same browser or for the same machine, that is a configuration information. So, there are numerous configuration settings just related to password. So, you can think of there are other configuration informations like what should be the for example, for a browser, what would be the you know, in what way the browser chooses the encryption algorithms, right. So, if it allows you multiple encryption algorithms, what should it choose? So, there are many such configurations, right. Now, if I want to tell you that look, if you want your system to be secure, you must have you must expire password every say 6 months, you must have a 12-character long password, you must have you know, mixture of different types of characters inside your password, and you must have 2-factor authentication. So, if I want to tell you these things, right, I can tell you this in natural language, right. Now, you will have to then go and find in your system, like if you now go back and try to find in your Windows how to set these things up. You can do it. I mean, you can Google it, you can ChatGPT it, and you will find how to set these things up. But if you want a machine to do this, right? If you want a software to go and check all these things and say, okay, so your password does not expire ever. So, you have a mistake in your configuration, and mistake, who says it's a mistake? Because my advice, it is against my advice. My advice said you have to expire it every 3 months and you are not expiring ever, or you are expiring in 1 year. So, you are non-compliant with my advice. So, to say all this automatically, I have to have two things. I have to have a way to tell my advice in a machine readable way, right. So, I should be able to write what I am advising you as a machine readable way, and that is what I call benchmark, configuration benchmark. So, in the configuration benchmark, I will write in a machine readable way that these are the things that I think is a secure configuration. Then you will have a software like you know, SCAP, which will take the benchmark file and run on your system and see whether, you know, whether each of these cases, each of these advices are actually being implemented in your system. If not, it will give you a list of errors or list of non-compliances. Does not mean that my advice was correct. Maybe Microsoft has shown that if I change the password too often, it is actually unsafe, right, because people tend to do various kinds of shortcuts if you push them to do password change very often. But that is not the point. When I create a benchmark, does not mean that I know the best, but I have created a benchmark and I expect you to be compliant. Whether I am right or wrong is another issue. In order to be right or wrong is, so usually it would be the CISO's team who will create the benchmark, right. He will probably derive the benchmark from US DOD or CIS benchmark, but he will create the benchmark, he or she or his team will create the benchmark, and when the benchmark is created, it is mandatory for every computer to be compliant in that organization to that benchmark this thing. So, I have to be able to name which configuration I am talking about. Am I talking about password length, or am I talking about password expiry time, or am I talking about how many mistrials will lead to lock, or am I talking about how long the lock is is going to stay. So, I have to uniquely name each of these configurations. So, that is what the common configuration enumeration is about. Then the next one is the platform enumeration. This is the one I was talking about, that I have to know which software I am talking about and exactly which version. Not every version of the software has the same problems or same configuration settings. So, I should be uniquely be able to talk about which software or hardware I am talking about. So, these three are enumeration type standards. So, how to name the vulnerabilities uniquely, how to name the configurations uniquely, and how to name the platforms uniquely. So, these are three enumerations. Next one is a metric. So, you might have seen this, that this vulnerability has severity 10, or this vulnerability has a severity 8.5 or 7.1, etc., right. So, this how to measure the severity of a vulnerability, that is CVSS. So, this is also a very important one, because it allows you to decide which vulnerability to fix first. If you have a severity 10 vulnerability and a severity 7.1 vulnerability, you will certainly fix that severity 10 vulnerability first, right. Now, the question is, why does this metric tell you that that severity 10 vulnerability is more important than severity 7.1? We will see how this CVSS is calculated, and then it will be kind of clear to you. However, now this CVSS is also come under criticism. CVSS is often, for example, a vulnerability that is, for example, suppose you have a Windows 10 and you have not lots of vulnerabilities, but suppose you never connect your machine to internet, right. Then it does not matter whether those vulnerabilities are there or not. However, there may be a vulnerability which is related to plugging in an USB to your system, which has a lower vulnerability, but since you do not connect to the internet, but you often get USB stick connected maybe that vulnerability is more important for your device to fix, right. So, there is a new notion called EPSS, exploitability score, right. See, exploitability is different from severity, right, whether a particular, so the exploitability depends on a context where this device or software is going to be used. But we'll not get into that, but I just wanted to say that this is the only one in the SCAP suite of standards which is a metric, which is not an enumeration or a language. So, 3 enumerations, 1 metric. Now the languages. So, the first language, the most common one is XCCDF, which stands for Extensible Configuration Checklist Description Format. So, checklist, that is, as I was saying, that my advice that this configuration about password have you done, this configuration about the password have you done, this configuration have you done. So, that is the checklist, right. And how you do the checklist, how you write the checklist is about this language, right. So, this is a language in which you can write the configuration checklist, and it is extensible in the sense that I can take your checklist and I can modify it or extend it to suit my purpose. So, that is why when I take the one from Department of Defense or from CIS, I can extend it. So, that is why it is extensible, but it is a configuration checklist description format. So, it is a language for describing the benchmark, and the benchmark that is created is called often called STIG, or Security Technology Implementation Guide. So, that is one language. The second language is OVAL. It is the Open Vulnerability and Assessment language. It basically says how to test for specific vulnerabilities. So, I can write a benchmark about vulnerabilities that I want you to test, that whether your system has an XZ vulnerability, whether your system has a Log4j vulnerability, whether your system has XYZ SSL, some SSL vulnerability, all that stuff I want to check. So, I will write a file in this language, and I will use a tool which will accept this file as input and then run those tests on your system and tell me whether you have those vulnerabilities. And then there is an open checklist interactive language. This is more for user interaction and it is not so important, so we will not discuss this in detail. So, all of you probably know about this CVE. CVE is the Common Vulnerability Enumeration language. So, CVE is written as CVE and then year and then the number. And the way the numbering is done is actually there are many, so earlier everybody had to go to MITRE and report a vulnerability, and then MITRE will contact the vendor of that software and ask for confirming that vulnerability, and then MITRE will actually give a number to the vulnerability and publish it in their database, right, so that the whole world can see it. However, now the number of vulnerabilities have increased so much that they have given chunk of numbers, a sequence, a kind of a window of numbers to various organizations. For example, in India, CERT-IN, the Computer Emergency Response Team, can give you CVE numbers. Once they have filled in all the numbers given to them, like if you discover a vulnerability, you can go to CERT-IN and say that, okay, here is a vulnerability, you check it. If you are satisfied that it is indeed a security vulnerability, you give a number to it from the set of numbers given to you by MITRE, and then once you are satisfied, you tell MITRE that this has been assigned and this is the details of this vulnerability, then MITRE will include it into the database. So, that is how currently this CVE numbering is happening, right. So, yes. It is actually, I think NIST give funding to MITRE and MITRE maintains it, I think. So, so that's the CVE enumeration. So, so we can see that it is used for correlating vulnerability information, and it is widely used. Many vendors and security researchers publish CVE names in their bulletin. There are, this is low estimate. I am pretty sure it's much larger than this. This is probably 100,000 per year number of vulnerabilities. And the National Vulnerability Database, which annotates the CVE entries with additional information, and this is what we are going to look at in the next class. So you can okay, so here is, so you can actually go to NVD database and then you can look at vulnerabilities, you can search, right. So so there are APIs through which you can actually have your tool connect to this database. You can also look for specific vulnerabilities and so on. So since we are out of time, so we'll actually look at this a little more in the next class. So the one more thing that is associated with this is from MITRE, which is a common weakness enumeration, or CWE. So we'll talk about CWE and CVE, the relations, in the next class. Okay, so that's it for today.